right. Make sure you have everything cleared off your desk except for a clean sheet of paper and a pencil. Clean sheet of paper and a pencil. Everything else away. We're going to take quiz 18. And so if you would put your first and last name at the top of your paper along with today's date. Today's 11/10/21. 11/10/21 is today's date. And this will be quiz 18. Quiz 18 that we'll be taking as we start the hour today. As you take a look at quiz 18, pretty straightforward. There are 9 identities I need you to finish. I've started them. You finish them. As you do, make sure you're careful to use the lettering that I have used for the angles. For some of these, there may be more than one correct answer. List the one you're most confident in. Okay, you don't get extra credit for listing them all, so what you don't want to do is list 3 of them and accidentally miswrite one. So list the one you know for sure. I guess if you want to show off, I'll put a smiley face on your quiz, but otherwise there's no reason to write all 3. Just write one of the 3 for those couple of identities that have multiple forms. All right, you may begin. Make sure you use that quiz copy as a cover sheet. And when you finish, just turn your paper over and sit quietly.
Did you say we could write one for the ones that have multiple?
Yeah, there's more than one, just pick one of them to write. You don't have to write off all the forms.
I thought I heard that.
Take about 2 more minutes to be finishing up. It's going to be finished with that quiz. If you would go and take your homework out, and turn your textbooks to page 129. Page 129. You had 2 identities to verify on page 129, and then on page 128, you had 3 problems to work practicing with your half angle identities. Take a look at all of these here now. So starting by looking at page 129, you did numbers 35 and 40. And then on page 128, numbers 2, 4, and 6. There's the 2, 4, 6, there's the 35, there's the 40. 2, 4, 6, 35, 40. And 40 looks like it was a pretty short one for you there. There's 2. 2, 4, 6. Okay, there we go. I see it now. And you said 6 is on the other side? That's 6. Okay, make sure we actually write the original problem down. That's going to aid you in being more accurate. Again, the work you put into homework will come out in the work that is produced on quizzes and tests. So the more effort you put in practice is the more profitable production in competition, so to speak, unlike Allen Iverson's philosophy.
I have a question.
Talk about practice? Yeah, homework is important. Yes, sir.
So on the quiz, will you...
We'll talk after.
Okay.
If it's a question about the quiz, ask me after the recording. All right, number 35. Let's take a look at it, where we were given that the cosine of gamma minus the sine of gamma is supposedly equal to the cosine of 2 gamma over the cosine of gamma plus the sine of gamma. And they want us to verify that this really is true. Which side should we start on, Chris? So looking at number 35 from the homework. Which side should we start on?
I start on the right side.
On the right-hand side, not because it even necessarily, quote, looks more complicated. There's something that guarantees it's more complicated.
The fact that there's a double angle.
The fact that there's a double angle. Anytime the angle isn't normal, it's doubled, it's tripled, it's quadrupled, it's halved, whatever, that tells you that's the side we want to start on. And now when it comes to the cosine double angle, we actually have some options here, don't we? Quentin, which option did you choose for rewriting the cosine double angle?
Cosine squared minus sine squared.
Cosine squared gamma minus the sine squared gamma all over the cosine of gamma plus the sine of gamma. And it would be tempting, wouldn't it, to say, well, let's cancel these 2 cosines to leave us with a cosine. Let's cancel these 2 sines to leave us with a sine. But are we allowed to cancel terms, class? No, we are only allowed to cancel factors. So Jamie, what do we have to do next?
Because multiply, like to change the denominator, can multiply by the conjugate.
You could, but I don't wanna. We don't cancel terms, Jamie. We
could,
cancel
factors.
factors.
So we could turn the cosine squared to cosine times cosine.
Ethan, helper?
Cosine gamma minus sine gamma, because you canceled one of them.
Ooh, careful. I just said we can't cancel. So make sure you're listening. We can't just cancel terms away.
I thought you said that part reason, because
No. Okay, so if I had an x squared minus y squared class, thoughts?
Some difference.
Yeah, that's a difference of squares. They could factor into a sum and difference. What would the sum and difference be, Jamie?
That'd be the cosine.
Well, in this case.
Oh, x and x plus y, x minus y.
Here we go, x plus y, x minus y. Well, here it's a cosine squared gamma minus a sine squared gamma. How would that factor, Ethan?
cosine plus sine cosine minus.
There we go, cosine gamma plus sine gamma minus sine gamma. And down here, this cosine gamma plus sine gamma, it doesn't factor, right? It's not anything special. So if it doesn't factor, I said in algebra, just group it. Technically, it's grouped by the fraction bar, but seeing the visual grouping can help our understanding of what comes next, because now, Chris, what can we do?
Cancel.
The
Clauses. The cosine gamma plus sine gamma.
Good, the quantity cosine gamma plus sine gamma that's in both numerator and denominator, and it leaves us with
Cosine gamma minus sine gamma. And that's it.
and that's what I wanted. The key here, though, was Quentin starting with this form. How did you know to start with this form? Well, look on this side. We have both cosine and sine, right? Why would I go with 1 minus 2 sine squared? Or 2 cosine squared minus 1? Why would I go with a form that doesn't have both sine and cosine in it when I want sine and cosine on the other side? So good choice of form. Spot the algebra steps. We know how to factor. We need to make sure we're careful in our factoring. All right? We know how to factor a difference of squares. We've known for years. Split the difference of squares into sum and difference. Cancel from there. Questions 35. Anyone get 35? All right, Quentin, good. Did you do it the short way or the long way?
I did that one.
Hey, good. Also, hey, progress. All right. Looking at number 40, we have the cosine of 3 omega, and we want to verify that that's equal to 4 cosine cubed omega minus 3 cosine omega. And which side should we start on here, Ethan?
The left side.
Good, because an angle that's not a normal plain old angle is always more complicated. How did I say we should rewrite 3 omega?
Cosine omega and then plus 2 omega.
Good, omega plus 2 omega. And since we have cosine with a sum or difference, I need to work with the sum difference identity for cosine. What is cosine's sum difference identity, class?
Cosine, cosine, plus or minus sine, sine.
Yeah, cosine, cosine, sine, sine, sine. So we write it out in cosine, sine, S-I-G-N, changes to a negative, sine, and of course we drop in the omega and the 2 omega. The omega and the 2 omega. All right, but we still have something that needs to be taken care of here. What do we still have to deal with here, Jamie?
Oh, those are double angles.
We still have double angles. So we took care of the triple angle, but we still have double angles. Now we need to take care of those. And so I'm going to keep the cosine omega. Now there's 3 ways to write cosine 2 omega. Which one should we choose this time, Quentin?
The cosine squared omega minus 1.
Good, the 2 cosine squared omega minus 1. I wasn't sure if I heard the 2 or not. 2 cosine squared minus 1. And then here, you don't really have a choice. There's only one form of sine 2 omega, Chris, and that is?
1 minus 2 sine squared.
Oh, sine 2 omega only has one form.
Oh, sine 2 omega. Why am I so confused?
Anyone?
2 sine omega cosine omega.
2 sine omega cosine omega.
I missed that one.
Uh-oh. All right, so, careful. At this point, I've got a monomial times a polynomial. Back to Chris, what do I need to do?
Multiply. No, that would just bring you back to what you had, wouldn't it?
No, I need
Multiply through, so
to...
you'd have 2 or 3 cosine.
Careful, what's a cosine times a 2 cosine squared?
Oh, 2 cosine cubed minus cosine.
There There we go. And then here, do I have to distribute, class? Is this a polynomial? No, this is just straight up multiplication. A negative sign times a 2 sine cosine would give me what, Jamie?
Right. So we're
If I have negative a times 2ab,
you
sign number letter,
is 2, or like it's negative 2 a squared b.
yeah, so here it's,
2 sine squared cosine.
there we go. All right, you see, it's just algebra. I mean, this is algebra, this is trig. Trig. But now we're back to algebra. In fact, we've got even more, well, no, we do need a trig step because there's a misfit. Ethan, what's the misfit?
Cubed.
Actually, no, because I see a cosine
Oh,
cubed on
yeah.
the other side.
The squared.
The sine squared. The fact that there's a sine, because there's not a sine anywhere else. This little guy right here doesn't fit in. There's nobody else like him. Which some would say it makes him special. I say it makes him in the way. So how do we get rid of this obstruction, Ethan? I was about to call him, no, I think I want to stay with Ethan for a minute here. Got a 2 cosine cubed omega minus cosine omega minus, I've got a 2 and a cosine omega, but I want to rewrite the misfit. Everybody else, let me look at everybody else. Look how they're dressed. Everyone else is wearing cosine. So why don't we have him change so he'll look like everybody else?
I had.
How
This is back to our other identities, correct?
Yeah, the identities we can't forget.
Yeah, I know. What did I forget? I'm sorry.
How about a Pythagorean
Yeah,
identity? That
yes,
has sine
that
squared
one,
in it.
that one.
Yeah, what is the Pythagorean identity with sine squared in it?
Cosine squared omega minus 1.
Sine squared plus
yeah,
cosine
well, that one.
squared
I was going.
equals 1. So how do I get sine squared? What would I get if I had sine squared by itself?
Sine squared equals 1 minus cosine squared.
There we go. We can replace this with a 1 minus cosine squared omega. I mean, we were doing this 2 weeks ago, right? Like, we know how to do that. It's just, we haven't used it quite as often, I suppose, lately. We definitely don't want to forget those. So if I had a negative 2 times a 1 minus x squared times x, monomial, polynomial. Well, you could look at this, because it's all within the same term in a sense, and you could think of this collectively, class, as a negative 2x. And really, just distribute a negative 2x, right? That would be easier, rather than distribute a negative 2 and just think of it as a negative 2x being distributed. Oh, here, let's think of this as a negative 2 cosine being distributed, Chris.
Negative 2 cosine plus 2 cosine cubed.
And of course, over here, we saw this 2 cosine cubed omega, negative cosine omega. At this point, let's see, Quentin.
At your turn.
Yeah, I got a 2 cosine cubed here and a 2 cosine cubed here.
4 cosine cubed omega minus 3 cosine omega. And that's what you want.
That's exactly what we wanted. 4 cosine cubed omega minus 3 cosine omega. So I noticed as I was going around, some of you had very short work on these, and too short. It should not have been that short, because this to me is the only real way to do this, the shortest way to do this at least, and we left some stuff out. Questions on this?
We're not going to have a quiz over this.
Gotta know your identities. Got to know your identities, and you've got to be able to think through algebra steps. Got to be able to think through factoring. Got to be able to think through distribution. Distribution again, combining like terms.
So this is literally just combining everything we've learned in algebra together.
Yeah, it's kind of a culmination of everything.
This is what we worked 3 years to do.
No. This is still building towards other stuff. All right. So speaking of building toward other stuff, look back across the page 128, where you did numbers 2, 4, and 6.
Yeah.
And let's take a look at these half-angle identities. Again, we've had special angles, 30, 45, 60, 90 for a long time. They were special angles last year in geometry. And then this year we introduced the idea that you could have special angles in other quadrants. So we went into quadrant 2. We had 120, 135, 150, 180. We went to quadrant 3, quadrant 4. And then sine, cosine, cosine, sine, cosine, cosine, sine, 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 poof. Now you can add them together, subtract them to get special angles. Now we can cut them in half to get other special angles. That's what we were doing here, for instance. Number 2, the tangent of 67.5. Well, I won't exactly say that that's a special angle, but it's half of one, Jamie.
It's half of 135.
So the first thing we ought to do is rewrite this as the tangent of half of 135. How many have that initial step correct? Then we need to write one of our tangent half angle identities. Chris, which one?
1 minus cosine over sine.
Good. 1 minus cosine theta over sine theta. Though instead of actually writing the theta, let's instead put what angle, Quentin?
Oh,
45.
Don't
Oh,
listen to Chris.
135.
135. Now, although we write 135, to an extent you're not entirely wrong because we're thinking what reference angle anyway. But we need to write the 135 so we don't forget to also account for the quadrant that 135 is in.
2.
Quadrant 2. Cosine of 45,
Square root 2 over 2.
and in quadrant 2,
Negative.
Ethan, the sine of 45,
it is square root of 2 over 2.
and in quadrant 2,
It is negative.
ooh, ASTC?
Oh yeah, positive.
Positive.
I was
All
thinking
right.
cosine.
I hear I have a back-to-back minus negative, Jamie.
That's just positive.
Really just a positive. We kind of cross it out that way. And I said a quick way to clear the fractions. That's lazy right there. Quick way to clear the fractions class is to multiply every term, every item within the fraction by
2.
2. What do I get when I do that, Chris?
2 plus square root of 2 over 2. Over square root of 2.
There we go. Here, multiply 1 by 2, of course, that's 2. Here, the 2's cancel. There's the square root of 2. Here, the 2's cancel. There's the square root of 2. But you can't leave a square root of 2 in a denominator. That's irrational. So we have to multiply the square root of 2 by, say,
Square root of 2.
square root of 2. Because that would give me the square root of 4, which is just 2. But once you do it at the bottom, so the top I also got to multiply by square root of 2, but this time I'm distributing the square root of 2 in to get Jamie.
You'll get 2 times the square root of 2 plus 2.
There we go, plus the square root of 4, which is 2. And now I can divide each of these separately by the 2 to get what final answer, Quentin?
Square root of 2 plus 1.
And there's my answer. That's the tangent of 67.5. I suppose you get your calculator out. Go and take the tangent of 67.5. And what do we get, Ethan?
2.4142.
All right. Now, in your calculator, take the square root of 2 and add 1 to it. What do we get?
2.414.
Yeah, same thing, right? So to an extent, you can even verify your answers on the calculator when you're finished. Questions on this? How many got that answer? Square root of 2 plus 1. Ooh, questions?
I did square root of 2 minus 1.
Okay, because you forgot to account for the quadrant.
Yes.
Okay.
I had negative square root of 2 in parentheses 2 minus square root of 2 over 2. I just didn't.
Simplify. It sounds like we just didn't finish the simplification.
I just didn't favorite distribute the square root of 2.
Okay, all right. Questions? All right, let's take a look at number 4, where we have the cotangent of 5 pi over 12. And again, when it comes to radians, my special denominators are 2, 3, 4, and 6. That's it. 12 ain't one of them. But I could rewrite this, Chris, as half of
5 pi over 6.
5 pi over 6. And there's my special angle denominator 6 I wanted. And for the cotangent, of course, we don't have that special half angle identity for cotangent. I would just take the reciprocal of one of my tangent forms. Which tangent form do we want to flip, Quentin?
Sine over 1 plus cosine.
We want to flip sine over 1 plus cosine. Again, 1 minus cosine over sine or sine over 1 plus cosine. But if I pick this one, then when I flip it, it becomes
1 plus cosine over sine.
1 plus the cosine of 8 theta over the sine of theta. And in this case, my theta, Chris, is
5 pi over 6.
5 pi over 6. Anytime I have denominator 6 class, I know the reference angle is going to be 30 degrees, and it's 5/6 of a pi, which would be in quadrant
4.
Well, here's a whole pi here, right?
Oh, 30.
Almost a whole pi. Quadrant 2. Right? 6/6 here, 5, 6, 4, 6, 3, 6 would be half, right? And then, but quadrant 2. So, Jamie, what is the cosine of 30?
3 square root 3 over 2.
And in quadrant 2, cosine is?
Negative.
And the sine of 30, Ethan?
It is 1/2.
A half. And in quadrant 2?
It is positive.
Positive. All right, the quick way to clear the fractions out, class, would be to multiply everything by a
2.
to get what, Jamie?
To get 2 plus the square root of 3 all over
Well,
1.
negative plus a negative, or just negative square root of 3.
All over 1.
All over 1. And do I really need to put anything over 1? So there's that. And there's our answer. Again, a little harder. You could put your calculator in the radian mode and take the tangent of 5 pi over 12 and then take the reciprocal of that. It's a little obnoxious having to do it, but you know what? Let's practice. Let's practice. It's good to know how to use radian mode. And so, again, the DRG button will push you over till it says rad at the top, and then 5 times pi divided by 12 equals. Take the tangent of that, then take the reciprocal of that. And what is the cotangent of 5 pi over 12?
I have 0.2679, but I don't know if
That's correct.
Oh, it is.
Yeah, that's right. Why would you think that wasn't right? Yeah, because it's a weird number. They're always weird numbers. Now, Ethan, did you get that? Because you said it was really easy on your calculator.
I'm there.
All right. Oh, you don't have.
Yes.
Well, you don't actually need one for what we're doing, actually. So.
Yeah, that's
It's not worth a rental right now. All right. You just trust that the rest of us are telling you the truth. Did you get it? Okay. Now,
Chris, did you get it?
take 2 minus the square root of 3. 2 minus 3 square root equals. And sure enough, 0.2679, blah, blah, blah. Now, is that a good way to solve it? No. It's a horrible way to try to solve it, but it's a great way to check it. Make sense? Now, before you do anything else, put the calculator back in degree mode. Or in physics, you're going to be in real trouble. For instance, if you type in 45 and take the tangent. 45 degrees, the tangent should be 1. But when it's in radian mode, it thinks you want the tangent of 45 full radians. Remember, 6 radians to a revolution. So you've just done over 7 revolutions, took the tangent of that. Yeah, you don't want that. So make sure it's back in degree mode before we hit physics later on today. All right, I've got a meme or whatever I put up on the board at the end of the year. It's like, calculator giving weird results? Yeah, radians. And it'll do that.
What do you mean by that? Yeah, radians.
Yeah.
Radians, if it's in radian mode.
Is that a play on words or something?
Well, the meme is actually with the actor like blames everything on aliens. It's one of those guys who's like,
Oh,
yeah,
aliens.
weird results, yeah, aliens. So it's kind of a play on that. But the truth I was deriving from the meme is that if your calculator is really being strange, make sure it's not in radian mode somehow by
How often
accident.
does that happen?
Since we generally don't use our calculators in this class, shouldn't happen too often.
Not us in this class, in any class.
But if you were using radians, for instance, college level, if they want you to get calculated values off of radians, and you're always putting your calculator in radian mode for that class, and you take another class where you need the degree mode, it could cause a problem. So this class, we almost always stay in degree mode anyway. All right, let's take a look at number 6. Last of all, we're at the sign of negative 11 pi over 12. Thoughts on this whole negative?
Pull it out to the front.
Yeah, let's just pull it out to the front. I don't want to add 2 pi. I just want to pull it out to the front and get negative sign of 11 pi over 12. To me, that's going to be a whole lot easier. You agree? Now, the next thing I got to do, its denominator 12. I'm going to rewrite this, Jamie, as...
11 over 6 or 11 pi over 6?
Well, but not 11 pi over 6, but rather half
yeah.
of the 11 pi over 6. Now, we hadn't seen this yet because tangent, cotangent, we have a form that doesn't involve a radical. Sine, the only form we have, does have a radical, Quentin.
No.
Sine half angle?
That's half angle. So,
Uh-oh.
plus minus the square root of 1 minus cosine over 2.
There we go. And what angle are we going to put here after the cosine, Chris?
11 pi over 6.
The 11 pi over 6.
Yeah.
Now, remember I said the positive negative right here does not mean that we're going to have 2 answers. It's a choice you have to make. And it's based on this original problem here. 11 pi over 12 and the sign that goes with it. What quadrant would 11/12 of a pi be in?
4. No.
1 pi is here.
2.
This is 2 pi. This is 1 pi. 11/12 is really close to a full pi.
Oh, yeah.
It is in quadrant 2. And sine in quadrant 2 is positive. So I should pick the positive, but
It's negative.
because we have a negative here, that's going to change what my usual choice would be. And so I will pick the negative, not because sine is negative in quadrant 2, but because we have a negative out front. That allows me to just roll with the negative as we go throughout, rather than keeping the positive negative. Hadn't seen that on the last 2 problems because they dealt with tangent. Coming here, the 11 pi over 6, reference angle, of course, 30 quadrant.
4.
Quadrant 4, because 2 pi would be 12/6. It's almost 2 pi. So it's in quadrant 4. What is the cosine of 30 degrees, class? Thank you, Jamie. Square root of 3 over 2 in quadrant 4, class. Cosine is positive. So I get 1 minus the positive square root of 3 over 2 all over 2. Once again, my recommendation, clear the fraction out by multiplying everything inside the radical by a 2 to get the negative square root of, Ethan.
2 minus square root of 3 over 4.
But we can't have a denominator in our radical, right? So we have to take the square root of 4, but that's easy. What's the square root of 4, class?
2.
2. So just have a 2. Leave the negative out front, and now the radical only applies to the numerator. And there's my answer. Negative square root of 2 minus square root of 3 all over 2. There we go. A little ugly having a radical within the radical, but there's nothing you can do about it. There's not a algebraic way to clear it, other than shy of actually typing the numbers into the calculator. Questions here? All right, let's do this one now, if you would. Find for me the tangent of 247.5 degrees. Find for me the tangent of 247.5 degrees. Ethan, what is our first step going to be?
Find the half of it. What the half is?
Yeah, it's half of what? And what do we get?
495.
495? All right, so this becomes the tangent of half of 495 degrees. Now, here I've got a little bit of an issue. Thoughts? Yeah, this angle's no problem, right? This angle's fine, but this angle's too big. Well, 495 is always exactly the same thing as any other coterminal angle. So now let's rewrite it as the tangent of half of
135.
135, and we subtract 360. Does that make sense?
Yeah, that is.
So it's a progression here. 247.5 is not half of 135. But the tangent of 247 will be the same thing as the tangent of half of 135. From here, which tangent form should I pick, Chris? Uh-oh.
1 minus cosine over sine.
1 minus cosine over sine. Okay, normally we'd write theta, phi, whatever Greek letter, but in this case we're going to write what in that angle spot, Jamie?
135.
135, but even as I write 135, I'm already thinking quadrant 2, reference angle
55.
Ooh.
Yeah, 45.
45. It's a good thing it's not 55. We couldn't do anything with it. And then, of course, we've got 1 minus something. What is the cosine of 45, class? Square root of 2 over 2. And in quadrant 2? Sine of 45.
Square root of 2 over 2.
Quadrant 2? Minus a negative? Multiply everything by
2.
to get what, Jamie?
2 plus square root of 2 all over square root of 2.
What do we need to do now, Quentin?
Multiply by everything by square root of 2.
To get what in the numerator?
2 times square root of 2 plus 2.
And in the denominator?
2.
Finally, Chris, we'll divide everything to get?
Square root of 2 plus 1.
And we're done. Questions on this? Do we see what to do if the angle that you take half of is too big? If it's negative, we're going to pull it out front anyway, right? Unless it's cosine or secant, then it just falls off. But if it's too big, coterminal angle rule to the rescue. Questions on that? We hadn't seen one of those yet. All right, let's take a look at number 10. Copy that one down if you would, please. The secant of negative 5 pi over 8. Thoughts right from the get-go, Ethan?
It's a secant angle, so it's positive.
Right, for secant, if you have a negative angle, like big deal, it just goes away, it just becomes 5 pi over 8. And now my next thought should be what, Jamie?
What is it the half of?
Good, because 8 isn't one of my special denominators for radians. So half of
5 pi over 4.
And then at this point, I should write out the identity for secant half angle, but of course that's going to be the reciprocal of cosine. Quentin?
1 plus cosine over, or square.
Normally we square root of 1 plus cosine over 2, but,
So
or over sine, excuse me, but no, over 2. But in this case,
plus minus the square root of 2 over 1 plus cosine.
and in this case, the theta that we plug in is the 5 pi over 4. Questions so far? All right. At this point now, 5 pi over 4, Chris, quadrant,
3,
3 reference angle.
16.
Anytime it's denominator 4,
45.
always a 45. What is the cosine of 45, Chris?
1, so square root 2 over 2.
Square root of 2 over 2, and in quadrant 3,
Negative.
negative. One thing I should have taken care of already, and I've jumped right into the angle there, I never picked a positive or negative. Well, go back to the semi-original, okay, after we cleared the negative out. What quadrant would 5/8 of a pi be in, class?
2.
Quadrant 2. Secant in quadrant 2 would be,
Negative.
so I'm choosing to keep a negative. I should have probably mentioned that first. Normally I try to take care of that positive negative first. Then we'll take care of the 5 pi over 4 states quadrant 3 reference angle 45. There's our negative square root of 2 over 2. Now what, Ethan?
Multiply everything by 2.
To get the negative square root of
4 over 2 minus 22.
ooh, but we have a denominator, and the denominator actually has has a radical in it. So we got this 2-term radical denominator within the radical. What do I need to do, Jamie?
Multiply by the conjugate.
What is the conjugate?
2 plus square root of 2.
And so that's going to give me the negative square root of, let's go to the denominator first. Quentin?
8 plus 4 times square root of 2.
Okay, we'll do the numerator first then. And in the denominator,
Sorry.
it's okay.
4 minus 2.
Good, 4 minus 2, square the first square, let's put a minus sign. 4 minus 2, of course, we could just write 2. And last but not least, I can simplify to get the negative square root of anyone?
4 plus 2 square root 2.
4 plus 2 square root of 2. Ooh, can I take the square root of the 4 and get a 2 out front?
No.
If it were a factor, yes. It is not. It is a separate term. We're going to leave it just like that big ugly answer there. Questions on this? Do we see what to do when the negative vanishes? Let's take a look at one more of these real quick. Number 12. We have the sine of negative 202.5 degrees. And let's start with Jamie.
Will you pull the negative out?
To get,
A negative sine of 202.5 degrees.
then what, Chris?
Figure out what the angle I want it to be is. So,
Okay.
Half of it is 4 over 5.
Good, this becomes the negative sine of half of 405 degrees. But thoughts, Quentin?
Negative sine half 45 degrees.
Yeah, it's too big. So we're going to apply coterminal angle rule, subtract 360, and it comes out to a nice, easy 45 degree. At this point, we need to write down what, Chris?
Well, I kind of speak 2 sine squared minus.
That's double angle. Leave the half angle.
Okay, so it would be 1 minus cosine of theta over 2.
Good, positive, negative, 1 minus the cosine over 2. And of course, the theta we're going to plug in there, Ethan.
45.
The 45. Before I forget, let's take care of the positive negative here by going back to the original here. Well, not the full original, but right here where we took the negative out. 202.5 class is in quadrant 3. Sine in quadrant 3 means I should choose the
Negative.
negative. But
You already have
since I already have this negative, that really means I wind up with a
positive.
positive. All right? The denominator, of course, is a 2. What is the cosine of 45, anyone?
Square root 2 over 2.
Once again, what am I going to have to do here?
Multiply by 2.
Everything by 2 to get what, Chris? Positive square root of?
2 minus square root 2 over 4.
And again, it's okay to have a radical within another radical, but you can't have a denominator. That's the no-no. So what do we wind up with here? Volunteer?
You would end up with negative square root 2.
Negative?
Oh. 1 minus square root 2. Because you end up canceling
Oh, no, okay. I need to take the square root of the denominator. Can I take the square root of 4?
2.
2. Can I take the square root of the numerator?
No.
Then just leave it as
2 minus square root 2.
square root of 2 minus square root of 2. What's the positive can sit out front? Does that make sense? Leave the numerator under the radical, get the denominator out of the radical by taking the root, and then leave the positive. Just like if I had the square root of 2/9. I can't take the square root of 2, leave it. I can take the square root of 9, 3. Same kind of thing. It's just weirder looking now. Questions on this? Look across the page 129 at number 29. Look at number 29. And let's go ahead and do a verification very quickly here. We have the square root of 2 minus the square root of 2 sine of a half theta times square root of 2 plus square root of 2 sine of half theta equals the cosine of theta plus 1. All right, which side is more complicated?
Left.
The left, because you have half thetas instead of regular thetas, and it just looks nasty. Now, here's a strategy tip. I could rewrite my sine half thetas, I suppose, but I see something else that's just screaming at me.
Some different.
A sum and difference, right? How do we multiply a sum and difference, class?
Square root square left, square left line.
Thank you, Quentin. Class, how do I multiply a sum and difference?
Square root of square root of square root between.
Let's try it in unison this time. How do I multiply a sum and difference?
Square root of square root of split minus sine between.
What do I get when I square the first? 2. Careful now. What do I get when I square the last?
2 sine squared.
2 sine squared half theta. And of course we put a minus sign between it. Now here's the beauty of this. We know that sine of half theta is a big ugly radical. Sine's half angle is an ugly radical, but I'm going to get to square it. So we've got 2 minus 2 times some big ugly radical that is about to be squared. So I'm not even scared by the radical. What is the sine half angle identity? Plus or minus the square root of 1 minus cosine theta over 2. And immediately, I get to square the radical. And whenever you square a square root, class, you get the radicand, right? Let's try that again. We should have that statement memorized. You're going to graduate soon. You need to have that stuck in your brain for college. When you square a square root, you get the radicand. Say that with me. When you square a square root, you get the radicand. So I'm going to keep this 2 minus this 2 times all of this just becomes what?
1 minus cosine theta over 2.
1 minus cosine theta over 2, because the square root cancels away the square cancels away the square root. Now keep in mind, this 2 is technically a numerator 2. It's technically, class, over
1.
thoughts
Cancel the 2's.
to just leave me with
2 minus 1 minus cosine theta.
2 minus the quantity 1 minus cosine theta. But algebra step, again, this was an algebra step canceling. This was an algebra step canceling. Now an algebra step, parentheses preceded by a negative.
Distribute negative.
To get?
10 minus 1 plus cosine theta.
And then you're writing this down.
And 1 plus cosine equals what we have.
That's what-
Equals cosine theta plus 1. Questions? All right, I wanted to do one more with you. We are out of time because of pizza day, even though I tried to move as quick as I could, so we'll end up doing that on Friday. Homework for this evening is to complete a handout. If you're watching on YouTube, you'll find the handout, of course, in the description of the video. It's been a little while, I guess, since we did a handout in this class, so I want to remind you of that. Homework is to do a handout. We'll take a look at this handout in our next lesson and plan for a quiz after we're done going over this. Of course, I'll just do the problem I meant to do today that we just ran out of time for. So we'll go over that problem, we'll go over the handout, plan for a quiz in our next lesson over half angle and double angle identities. The problems on the handout very similar to the problems you'll see on the quiz Friday. Have a wonderful rest of your day, and you are dismissed.